Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you for joining us on this edition of the Space Nuts podcast. My name's Andrew Dunkley, and joining me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hey, how are you doing, podcast host at large?
Yes, it's a bit like that sometimes, but yeah, I'm well. I'm quite well, surviving the inevitable weekly dust storms here in Western New South Wales. We had another one yesterday. We had a horrible day yesterday. It was cold. It rained enough not to be of any use to us in the middle of a very intense drought. It was really windy. It was cloudy. Then we got a bit of sunshine and then a dust storm. It was a hell of a day, and very cold, very, very cold for this time of year. Beginning of summer, and we were down into single figures. So, yeah, you figure it out. I can't. It's bizarre weather. How's your part of the world, Fred?
Much the same. We've got smoke as well, of course, from the bushfires.
We've had our share of that lately too. Yeah. It's your smoke. It just blew over here.
Actually, I think it's, to be technically correct, I think it's smoke that is generated between us, actually, up in the mountains there, between your inland western plains and our coastal strip. It's set on the mountain.
It's all those mountain people, Deliverance country. It's all their fault.
Yeah, I think. Yeah.
All right.
Having been involved with bushfires, I wouldn't go there.
No, it can be pretty tough. Now, we have got a large array of topics to cover today. We're going to talk about a supermassive black hole that's been found that ought not to be there, a planet with liquid water but no life, which
It's called the Earth.
Yeah, that's the one. And some questions, or a place on Earth with liquid water that doesn't have life.
Yeah, that's right.
What we're getting at, yes. And questions about the age of the universe from someone's grandmother.
No, grandfather.
Grandfather.
Pay attention, Andrew.
I'm going well today. A star that apparently went supernova twice.
Yeah.
I got that one right, did I? And Andrew Broadhurst has emailed us to find his place on Earth. We're going to do that for you, Andrew, hopefully. But first, a supermassive black hole. This is enormous, this thing. And it's been found where it shouldn't be. They don't think we should have one of these, but we do.
We do, yeah. It's a really interesting story from a number of points of view. And it actually has echoes, Andrew, of a story that we did not long ago, if my memory serves me correctly, which was about a black hole that was too small to be a black hole. But this one's too big to be a black hole, at least by our present understanding. It clearly is what these things are, but it's a remarkable thing.
So if it's too big and too small, it's not in the Goldilocks zone.
That'll be the problem. Yeah, the too small one, I think we covered a few weeks ago. I was just trying to look back in the list to see if I could see it, but I can't. But never mind. We're talking today about one that is bigger than has hitherto been thought possible for a black hole. And the story interests me partly because of the way it was discovered, because this black hole candidate was discovered using a telescope that I had quite a bit to do with when it was being developed. It's called LAMOST. It is a telescope in China. It's not very far from Beijing. LAMOST is an acronym. If I remember rightly, it's Large Aperture Multi-Object Spectroscopic Telescope.
I'll take your word for it.
Yeah, and it's a very unusual telescope, built in a very unusual way. I sat on a committee, in fact, two committees that looked at its work during the early part of this millennium. So I think it was 2005, 2009 or something like that. I was in China to help put this telescope, not put it together, but to plan it and plan what it would do. And I was very honoured to be able to do that. It's a project of the Chinese Academy of Sciences, very, very worthwhile, and now succeeding very well. It's one of these telescopes that uses optical fibres to analyse the light of many, many objects rather than just one or two. In fact, I think they can look at up to 4,000 objects simultaneously, which is pretty impressive. So what did they do? Well, they were surveying the team of astronomers, and it's led actually by a group from the National Astronomical Observatory of China, NAOC. That group used the Lamos telescope to look for stars that have a big range of velocity. So you're looking for something whose velocity changes over time, but changes quite significantly in terms of, it's what we call the radial velocity, the line of sight velocity, because that reveals something either going round the star or the star going round something. You're looking at the forward and backward motion of as the star orbits. Now, it's a commonly used technique for finding planets around other stars. Planets are invisible, but you can see the way the star is pulled backwards and forwards by the invisible planet going around it. But the same trick can be used for something much more massive, like a black hole. Yeah. Okay. So they used the telescope to find a candidate for something that had some interesting stuff going on, and then they followed it up with more, what you might call more targeted telescopes. Actually, two of the 10-meter class telescopes. Lamos, by the way, is a 4-meter class telescope, much the same size in terms of its mirror as our Anglo-Australian telescope here in Australia, and the Kitt Peak 4-meter telescope in Arizona. But the group doing the observing of this object basically followed up with two 10-meter class telescopes. One is the Gran Telescopio Canarias, which is on the island of La Palma. It's a 10.4-meter telescope operated by Spain with a number of collaborators, and one of the two Keck telescopes, which are similar classes. Actually, I think the GTC, the Gran Telescopio Canarias, was a copy of one of the Keck telescopes. Effectively, these were all in the 90s. These instruments were built in the early 2000s. The Keck telescopes, of course, are on the island of Hawaii, the big island of Hawaii at Mauna Kea. So those two telescopes were used essentially to follow up the details of what's happening with this star. What is it that's pulling it around, tugging it backwards and forwards? And the inevitable conclusion is that the star is in orbit around a black hole. And the black hole is calculated to have a mass of 70 times that of the sun. And that is a surprise, because people have really, until very recently, we thought that the stellar mass black holes, as they're called, ones with similar mass to the sun, were, to find one with 20 times the mass of the sun will be a big one. And then we had evidence from the gravitational wave detectors of things a little bit bigger than that colliding and forming even bigger black holes. And now we've got evidence for a single black hole that is bigger still, 70 solar masses. It's actually a record breaker. I think that is the largest known, or the most massive known stellar black hole. It's being called LB1, and I suspect LB1 stands for Lamost Black Hole 1. Yeah. And good on them. So I think the issue now is, how can a black hole of that size basically how can it be formed? One thing, a piece of information I forgot to add, Andrew, is that the star itself, the thing whose velocity is being measured, that's got 8 times the mass of the sun, but it's going around something much bigger, almost 10 times bigger, the 70 solar mass black hole. Its orbit period is 79 days. So it's, if you look at the theory of black holes, the biggest that you can make by what you might call normal methods, and that's by stars at the end of their lives collapsing in on themselves and forming this highly dense nucleus. It's about 40 to 45 solar masses, but this is, of course, much bigger. And one possibility for its existence is exactly what I mentioned a couple of minutes ago, a merger of 2 smaller black holes, which could easily form something this size. But then you've got to look at how that could have happened and still have a normal star, a relatively normal star in orbit around it, the one whose backwards and forwards motion has betrayed the presence of the black hole. So still many questions about this piece of astronomy. I think it's very, very interesting stuff. And it actually highlights, this was the common ground between this story and the one we covered a few weeks ago, in that these are black holes that are not revealing themselves by the fact that the companion star is pouring material onto the accretion disk of the black hole and making it blaze away in X-rays, which is the way that stellar mass black holes have conventionally been discovered. But this one has not been discovered like that, and it seems like one statistic that comes from the leader of this project is that there's about 100 million black holes believed to exist in our galaxy, but only a tiny fraction of that, perhaps 4,000 of them, can generate the X-rays that actually give you reveal the presence of the black hole. So this is a new way of finding black holes, and it's unearthing all kinds of interesting stuff.
Gosh, and if we've found one this big, does it stand to reason there might be something even bigger?
Yeah, I think it does. I mean, in a way, we know that there's no limit to the size of a black hole because we know already that probably all galaxies, but certainly many galaxies, have a supermassive black hole at their center. And I think the biggest one of those is many billion times the mass of the sun. So there isn't a limit to how big a black hole you can get. Maybe what we're seeing with these, 60, 70 solar mass black holes, the start of the process that leads to the supermassive ones, because the supermassive ones are thought to have formed by accretion of huge amounts of material around them.
Okay, wow. Well, I'm sure if they now that they've got a system that seems to give away these things, that it won't be long before we find another one.
Yes, I think that is probably true.
Yeah. All right. There we have it. A black hole that we thought could not exist does exist, and they have a new system for locating them now, which may open many, many doors and create many, many, many more questions. You're listening.
All of which will come to Space Nuts.
Yeah, that's very likely. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Once again, a big thank you to our patrons who put their money where their podcast is. We really appreciate your support. And Fred, our numbers have grown by -1 over the last week, which is awesome. Look, it's one of those things. People come and go, and they do it voluntarily. So, and any gesture that you make towards the support of our program is certainly wonderful. So, thank you. Now, we have got a situation on Earth, and you and I have discussed this many times in the past, where the old saying goes, where there is water, there is life. And that was something that we hoped would translate into the discovery of liquid water elsewhere in our solar system or other parts of the galaxy or beyond. However, it seems there is a place on Earth with liquid water, but no life. This sort of shuts the door in our faces a little bit on the old where there is water, there is life theory.
That's right. So it's a mantra that we can't use. I suppose you could change it to where there's water, there's usually life.
Yes, we're going to have to now.
But this is an interesting story about a really interesting place on Earth, which I confess I haven't come across before. And it is a geothermal area in Ethiopia. And I'm probably going to mispronounce its name, but it is Dallol, Dalol. Not sure. It could even be Dayol. It would be in a Spanish-speaking country. It's worth checking out online, the Dalol hydrothermal system, because the landscape has got the most astonishing colours in it, coming from some remarkable chemicals and reactions that are taking place within these geothermal pools. I've seen, I was in the Yellowstone Park a few years ago, and I think if I remember rightly, there's something called the Rainbow Pool there, which has some quite spectacularly coloured deposits. I hope I'm remembering this correctly.
Yeah, you see similar things in New Zealand around Rotorua.
You do, that's right. Yes.
Yeah, those thermal lakes are just some of them are just brilliant greens and oranges and blues. They're quite incredible.
But you have a look at Dalol, and
I'm looking at a photo of it right now.
Isn't it staggering?
You would think it had to be another planet. That just couldn't be on Earth.
The only thing that makes it look vaguely normal is a blue sky with little puffy clouds
in the background, yes.
Apart from that, it looks incredible. So why are we talking about this, apart from the fact that it is an extraordinary looking area? The research on this pool has looked at most particularly the fact that it is a very, very adverse area. The water is anoxic, no oxygen, hypersaline, huge amounts of salt, and hyperacidic. So it's battery acid as well. And that's sort of in many ways, it's the kind of environment that you say, well, if we're going to find extremophiles anywhere, this will be the place. And you throw into the mix that some of these pools are at a temperature of 108 degrees Celsius, which means they're boiling because you're at atmospheric pressure. It's a really very adverse environment for living organisms. Nevertheless, back in May, I think I'm right in saying this, a paper was published that I'm just trying to find the title of it, that basically said, well, we found things in these lakes that are microorganisms.
Ultra small microorganisms in the polyextreme conditions of the Dalal volcano north afar Ethiopia.
You took the words out of my mouth. That was a paper in published.
I just finished reading it while you were talking.
Very good. Did you enjoy it?
I don't understand a word.
So, and I'm quoting from the introduction. It says, "Here we report for the first time evidence of life existing within these hot springs, using a combination of morphological and molecular analyses." The idea was that there was evidence of life, and they quote again, entombed within mineral deposits. And where the life forms that they thought they'd found were sort of related to organisms that have been found in other hypersaline environments. So the combination of morphological and molecular analyses, that's the key to this May 2019 paper. Morphological just means that it looks like life. It means the shape is like living organisms. Molecular means that you've got some chemical similarities there with living organisms. However, what has now happened is a new paper has been published, also in the journal Nature, which has a number of authors, I think from Spanish universities. I need to check up on that. The lead author, I think, is Dr. Here we are. This is the lead researcher is Puri Lopez Garcia. And I'm just looking to find out what
Australian, mate.
Institution that is from. They are okay. That's terrible. But the works come from the Spanish Foundation for Science and Technology, which makes me think that they are Spanish investigators. It's a French-Spanish team, okay. And in fact, Dr. Lopez Garcia is from the French National Centre for Scientific Research, CNRS. So that's where that work originated.
You know why you didn't see that straight up?
Why was that?
It's in supermassive bold print.
That'll be right. That'll be right. I only look for the little words.
Yes, me
Being
too.
a small-minded person myself. But what they've done, they have essentially done a much more thorough analysis and have ruled out these structures having anything to do with life. They said their analysis shows that biological nature does not hold up under intense scientific scrutiny. This is quoting a press release. But quoting the authors, in other studies, apart from the possible contamination of samples with archaea, that's bacteria from adjacent lands, these mineral particles may have been interpreted as fossilized cells, when in reality they form spontaneously in the brines, even though there is no life. And that's a really interesting thing for me to read, because within the last few days, actually, over the last week, I've been corresponding with an astrobiologist. He's formerly from JPL, Jet Propulsion Laboratory, now working in Italy, who makes this point really strongly. And he's pointed me to some literature. Actually, some of it goes back to a book that was published in 1911, showing how chemical reactions among minerals of this kind can produce organisms that look for all the world like living organisms. And in fact, this book shows, mineralogical gardens. They're gardens and they've got flowers in them and plants and all kinds of growth, but they're produced purely by mineral reactions.
Yeah.
In fact, my colleague contact in Italy was basically drawing counselling caution, I guess is the way you put it, about some other work that I've quoted fairly freely in things I've written about a place in northern Chile, the El Tatio geothermal field, which I've visited. It's nothing like as spectacular in appearance as Dalol, but is still very impressive. But there are features there in the rocks which have been identified with features that were found in rocks on Mars by the Curiosity. Sorry, not Curiosity, it was Opportunity that found them. And that caused a lot of excitement. But my colleague is counselling against getting too excited because of this wealth of knowledge that's been built up over at least the last 100 years, that you can, mineral processes often give rise to things that look like and have similar molecular structure to living organisms. And that's exactly the outcome that this group, the French-Spanish group, have, or exactly the conclusion they've drawn about the hydrothermal springs at Dalol. They reckon that, yes, while the minerals look like living cells, microbial cells, they're not. They're just produced by chemistry. And, as you said at the outset, Andrew, that kind of pours a bit of cold water on the idea that wherever you find water, you find life.
Distilled battery acid water, as it turns out. Yes.
Yeah, exactly. It's not even here on Earth.
I saw the first draft of their media release when they sent this out. They said, remember that article in May of 2019 about life in Dalol? It's rubbish.
Yes, that's right.
I decided not to release that one, but I got a copy. But, one of the things you and I have talked about before is how life can exist in extremes. And even this article talks about life around thermal vents in the ocean, in caves, and even in fresh lava, and even in radioactive decay of uranium.
Yes, that's right.
So to actually find a place where life does not seem to prosper in any way or form is quite a shock.
I think that's right. That's why this paper is really worth taking note of, which is precisely why we're speaking about it today.
So it won't be where there's life, there's water. It will be where there's water, there's life. It will be where there's water that isn't distilled into battery acid. There may be life.
Yeah, that's right.
But as you and I have also discussed, there may be life forms that don't need water at all. They could exist in another kind of environment that they've adapted to over millions of years or whatever. So it doesn't absolutely write off the possibilities.
Not at all. No, that's right. I mean, we're excited about the methane and ethane seas of Titan, because there could be life forms in those that use those hydrocarbons as their working fluid rather than water. It's just that here on Earth, as you said, all life, it's certainly true that all life uses water as its working fluid, but not all water produces life. That's the bottom line.
All right. There'll probably be more discussion on this down the track, maybe some debate, I would imagine, but we'll keep an eye on that one, and we'll report back in if and when there's more to report back in on. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
And Fred, our numbers are building rather nicely on our YouTube channel, which is it's very, very good. All our episodes are on YouTube. We are pushing on relentlessly to the magic 1,000 followers. We've only got 1,000 to go. No, that's not true. 312 should do it. Another 312. Gee, my maths is terrible. I should be an astronomer. But no, 312 more and we'll hit the magic 1,000 followers on our YouTube channel. So if you're a YouTube lover, as I am, maybe just, subscribe to us and then just don't have to look again, but it gets the numbers up. I never said that out loud, did I? Now, let's get into some questions, Fred. And this one comes from a repeat offender named Miles Bradley. Hey, Fred and Andrew, sending another question your way. This one is from my grandpa. The determined age of the universe seems to be related to the distance of the farthest known discovered object, right? Wouldn't it have taken us much longer to become that far apart? Is the question from Grandpa Bradley. Well, I assume it's Bradley. It could be something else.
Yeah.
But, thank you, Miles, for sending your grandpa's question. Fred will answer in 20 words or less.
Do you want them in the right order? So the most, I guess the simplest way of determining the age of the universe, it's not really about the distance to the farthest known object. It certainly involves looking at distant objects, but what you do is you find a way of measuring their distance, and there are a number of ways to do that, usually involving a particular type of variable star called a Cepheid variable. So you find their distance, and you also look at how fast they're moving away from us because of the expansion of the universe. And then you can plot what's called a Hubble diagram. And the reason it's called that was because Edwin Hubble was the first person to do it, where you plot the distance of a galaxy against its velocity of recession, as it's called, the movement away from us. And that essentially gives you can basically turn that upside down and look at, you can say, so everything's moving away from us. That means that at some time in the distant past, we were all in one place, and you can essentially turn the equation upside down, and you can measure the time back to T0, when everything was in the same place. And in fact, if you do that, you get an answer that's slightly wrong. It's about 15 billion years. And that's partly because we now know that a lot of other things have happened in between. It's there are subtleties to this, but that's just the basic method. So just going through to the end of Miles Bradley's grandpa's question, wouldn't it have taken us much longer to become that far apart? So yes, you can look at distant objects and say they're a long way off, but they fit that relationship that I've just explained. It's more when you look right back to the beginning, when we see what's called the cosmic microwave background radiation, which is the flash of the Big Bang itself, that tells us that there was a time in the very early history of the universe when it expanded very rapidly indeed. The first gazillionth of a second, it went from, the size of a pea to the size of a galaxy in a tiny, tiny space of time.
It's just unimaginable.
It is, but the reason why I would believe that happened is there's no other way of accounting for how uniform that microwave background is across the whole sky, and so we know that there was a time when the universe expanded very, very rapidly, but the objects themselves within it all, they all fit the bill. Then they are part of the more sedate expansion that has taken place since that time. I'm really not answering this very well, but it turns out that there isn't actually a problem with the distances of the things that we measure. They are within the age of the universe, let me put it that way.
So wouldn't it have taken us much longer to become that far apart? No. So you could have done it in one word.
So I took not 20, but 1,020.
But hopefully that clears it up for Miles's grandpa. And thank you for the question, Miles. Really appreciate it. Good to hear from you again. Let's move on. Hello, Fred and Dave. Oh, this has got to be Brock. Got to be. Cheers from Canada. My question is related to an article which he sent us a copy of. In this article, it talks about a star that went supernova twice. And looking at the pictures, the supernova is a tiny dot in a distant galaxy. How can we be sure that it was the exact same star that exploded? Aren't there possibly thousands/millions of stars that could be in the vicinity of this dot in a very far away galaxy, or a galaxy far, far away even, Brock, that it could be. Thank you, as always, from your fan, Brock. Brock Pedersen. Thank you, Brock.
Yeah. Well, Dave, that was a really good question. I thought that was a classic one.
I've got a magic button here, don't forget.
I know, that's right. Look, Brock is absolutely on the money. It's a great question. So I've followed up the story, and I know you did as well. And in fact, I read the original paper that this is all about. And it comes from some work that was done or published in 2017, almost exactly 2 years ago. And it's about a star in a distant galaxy that went supernova. It became very, very bright, sort of outshining the rest of the galaxy, as supernovae do. And there are things about it that suggested that it was a fairly standard, I think, a type 1a supernova, which is one of the standard ones. I can't remember. I need to check up on that. But actually, subsequent observations revealed that it was far from normal, because, yes, it got bright and then it faded, but then it got bright again and then faded. Then it got bright again and then faded, then again, and then again, 5 times.
Wow.
Over a period of something like 500 days. That's getting on for 2 years. So this is completely different from the behavior of a normal supernova. It's clearly doing something else. It brightens and fades over this period, typically of the order of 100 days, something like that. So that was from an event that was observed in 2014. So it faded, got brighter, did it 5 times. Actually, in total, it was over 3 years. Still, really not fully understood. But what the scientists did there was saw that this thing had been discovered actually by a telescope very similar to our United Kingdom Schmidt telescope at Palomar Mountain near San Diego. That's one of the classic telescopes of all time, but they now operate something called what's it called? The Palomar Supernova Factory, something of that sort. It's got an unusual name. The Palomar Transient Factory. That's what the telescope is now called, and it looks for things that vary in brightness. So that was how they established that this thing was walloping up and down in brightness from 2014 for the next 3 years or so. But what they then did was look through archival data and look back through to older photographs of the same part of the sky. And sure enough, in 1959, they found a brightening. And that is, it was, beg your pardon, 1954, not 1959. The same area of the sky.
Fred celebrated his 40th birthday.
Exactly. That's right. Don't you forget it, you young whippersnapper. So Brock's question is on the money, because the 1954 event, I have a photograph of it right in front of me, is a faint smudge of a galaxy with a blob in it. And that blob probably encompasses, as Brock says, millions of stars that could be within that blob of light. But the odds are that it is the same object. And the reason for that is that this behavior is so unusual. And as I said, it's not yet fully understood. It is so unusual that the overwhelming likelihood is that object is the same thing that was shining in 1954. Now, just to cover the authors of this work, in their paper, which was published in Nature back in 2017, and it has a list of about, I would guess, looking at that, there's about 60 authors there. It's clearly a huge team. They describe the event. In fact, their first sentence is a great one. Every supernova so far observed has been considered to be the terminal explosion of a star. But this one clearly isn't, because over 3 years it bounced up and down, as we've said. But then later on in their abstract, they say, Another possible eruption was recorded at the same position in 1954. And so what they're saying is it's only a possibility, but it is the overwhelming likelihood that this was the same object. Now, they're not using that data from 1954 in any way to model what's going on with this object. For that, they've used the brightness measurements that they've made. And by the way, they've continued using an observatory fairly close to our heart at Siding Spring, the Las Cumbres Observatory, because one of their big 2-meter telescopes is there. There's another one on Haleakala, the island of Maui. So place that has associations with Australia. So they're using those telescopes to monitor the brightness of this object as it goes up and down, and essentially drawing the conclusion that it's probably the same thing that was bright in 1954. And there's a really good chance that that was the case, I think.
Prompts another question, though, Fred. Okay, what they're saying is this is a star that's gone supernova more than once. So the question pops into your brain is, how is that possible?
So, yes. So this is the exact mechanism of what this star is. And some people have speculated it is something called a pulsation pair instability supernova. And one of the co-authors of the paper comments on that, and he says, according to this theory, it is possible that this was the result of a star so massive and hot that it generated antimatter in its core. That would cause the star to go violently unstable and undergo repeated bright eruptions over periods of years. And then there's a calculation to say that before the first explosion, whenever that was, it might have been before 1954, the star was at least 50 times as massive as the sun and probably larger. Another of the co-authors comments that these explosions were only expected to be seen in the early universe and should be extinct today, and suggests that this curious object is like finding a dinosaur still alive today.
Wow.
And then he says, if you found one, you would question whether it truly was a dinosaur. It's a really interesting, piece of work that we don't really understand what has caused this, but it's something very unusual. And
it could pop off again.
It could pop off again. Yeah, well, it is doing. Certainly until when this paper was. Actually, I have to say that towards the end of the period that's covered by this paper, it was definitely fading to, below the level of, to almost the level of a normal supernova. It's a curious object, and the great news is that the Las Cumbres Observatory, their global telescope network, which is what they've got, is able to keep an eye on this part of the sky almost indefinitely. And so this global telescope network is probably going to show us whether there's another eruption and what that might look like. So it's an ongoing story, which I think is a very interesting one.
So probably most likely, almost definitely the same star rather than two separate stars or more. Yeah. Okay. Thanks, Brock. Appreciate the question. And it's thought-provoking, as always. Now, let's move on to a question from Andrew Broadhurst. Now, you're going to have to do some explaining here, Lucy. Hi, Andrew and Fred. I've purchased a 7-day electronic astronomic timer for switching on a dew control system in my observatory. Way too much spare time. The unit is from the USA and can be programmed for regions in the USA and will track and switch on at sunset and switch off at sunrise, advancing and retreating with the seasons. Please, can you assist me? No, you're beyond help. Is there a location in North America where the sunset and sunrise time exactly follow my latitude here in New South Wales? I won't read the latitude because then everyone will know where you live. But 6 months apart, of course. That way on, for example, 21st of December here, I can set the time at the 21st of June, North America, and that will track and operate the timer nicely for local sunset and sunrise. Thanks. Many thanks for the great show. Andrew Broadhurst from Bundook in New South Wales. Oops, I told you where he was. So he's looking for a place in North America that would equate to his exact position in Bundook, I'm guessing.
Yeah, that's right. And it's a great question because this timer is a very clever timer. It knows what season it is, so it knows not to switch the dew control system on.
So do flowers.
Midway through the afternoon.
They haven't got brains. Anyway,
but flowers can't be hooked up to a dew control system, Andrew. What do you think of that? Anyway, never mind. So a great question, but it's like many things that come from the United States, it's only programmable for the United States. So his question is a great one. What can you do? How can you find a place in the United States that would mimic the change of seasons, the change of day length here in Australia? But 6 months out of phase. That's the bottom line. So exactly as he says, on the 21st of December, the summer solstice here, you can set the timer as the 21st of June, summer solstice in North America. And you can do that. So all Andrew really needs to do is to find a place in North America that has exactly his latitude. And I'm not going to go, we haven't time in the show to do that. I should have checked this up before. But it's certainly within the latitude of mainland North America, the latitude range. So find a place with the same latitude and set, as you say, Andrew, a 6-month time difference, and it will work. There is one proviso here, though, that those two places on opposite sides of the equator with the same latitude, they mimic the sun's motion over a period with a 6-month time delay in terms of sundial time, not clock time. And that's because the Earth's orbit is elongated, and so you've got to take account of the elongation of the Earth's orbit with something called the equation of time. And what that does is make sundial time and clock time differ by up to 15 minutes or so. I think it's 16 minutes altogether. So if you're happy with the thing not being good to the nearest minute and being good to the nearest quarter of an hour, then that's all you need to do. If you want it exact to the nearest minute, you've got to think again, and so do I, because I'm not sure how you would do that.
Are you going to do some homework and email him back with his coordinates?
Yeah, I might actually look for somewhere in North America that's got the same coordinates. How's that?
Okay, that sounds like a good idea.
Does, doesn't it? That'd be a nice thing for me to do.
Didn't mean to dump you into it, but I thought, because that's what he wanted.
Yeah, exactly.
All right, Andrew, good luck with that. No, it was fascinating, though. I'm still trying to figure out what he's actually using.
It's a flower.
Ah, well, that's all I needed to know. They follow the sun. So, yes, all right. Fred will get back to you shortly with your coordinates for North America in the same vicinity of your current location. So don't move. If you move, you'll have to do it all again. Would be a bad move. So thank you to everyone who contributed to our Q&A this week, and thank you, Fred, as always, for filling us in so eloquently about the mysteries of the universe. It's always great fun.
It's great to talk to you too, Andrew, and long may it continue.
You did talk to two Andrews, at least.
I did, yeah.
All right. We'll see you next week.
Yeah, sounds good.
Fred Wilson, astronomer at large, one of two people who wonder why they ever get out of bed of a morning, but it is because we love to do Space Nuts. And we love that you enjoy it so much, and thank you for all the positive feedback. We do get so much, and it's terrific. And don't forget to tell your friends, if you've got any. I mean, if you're an astronomer, you probably haven't. But we will catch you... Look at your face. We'll see you next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.